Have you ever wondered how a microcontroller creates delay, blinks an LED, or counts button presses? All of that is done using timers and counters. In this video, I'll explain 8051 timer and counter from basics to code. Very simply, why do we use timers and counters? Microcontrollers are very fast, but they don't understand time by default. We use timers and counters to create time delays, measure time intervals, count external events, generate baud rate, control real-world devices. Without timers, no blinking LEDs, no clocks, no serial communication. Timer versus counter. Basic idea. A timer counts time using the internal clock. A counter counts events using external pulses. Important line. Timer and counter use the same hardware, but different input sources. Stopwatch timer example. Blinking an LED every 1 second. Digital clock. Creating a delay in a program. Counter exam. Counting button presses. Counting people entering a room. Counting motor rotations. How many timers and counters in 8051? The 8051 microcontroller has 2 timers. Timer 0, Timer 1. These can work as timers or counters. How to verify timer or counter mode. This is controlled using the TMOD register. C/T bit most important. C/T equals 0 timer mode. C/T equals 1 counter mode. Check the C/T bit. 0 means timer, 1 means counter. TMOD register. Gate. 0 timer controlled by TR bit only. 1 timer runs only when TR equals 1. An external interrupt pin is high. C/T. 0 timer, 1 counter. M1, M0 mode selection. TH and TL registers. Each timer is 16-bit, made of 2 8-bit registers. TH, high byte. TL, low byte. Timer equals TH-TL. TL increases first. When TL overflows, TH increases. When both overflow, timer overflow. Overflow flags. When timer reaches its maximum value and resets to 0, it overflows. TF0 equals 1, timer 0 overflow. TF1 equals 1, timer 1 overflow. Used to detect delay completion. Timer overflow. When a timer reaches its maximum value and increases by 1 more, it resets to 0. This condition is called an overflow. In 8051 example, 16-bit timer, mode 1. Maximum value equals FFFFH65535. FFFFH plus 1, 0000H overflow. When this happens, TF0 equals 1 timer 0 overflow flag. TF1 equals 1 timer 1 overflow flag. Why overflow is important? Tells the microcontroller that time delay is completed. Use for delay generation. Interrupts. Baud rate timing. Event counting. ING. Overflow happens when a timer reaches its maximum value and rolls back to 0. This is how the microcontroller knows that time has passed. How to start the timer. Using TR bits. TR0 equals 1, start timer 0. TR1 equals 1, start timer 1. Generate a delay using timer 0 in mode 1, 16-bit. TMOD equals 01H selects timer 0, mode 1. TH0 and TL0 load initial count value. Set TR0 starts the timer. TF0 becomes 1 when overflow occurs. Program waits until overflow happens. Timer is stopped and flag is cleared. Timers and counters allow the microcontroller to interact with real-time and real events. If you master this topic, embedded programming becomes much easier. Like, share, and subscribe for more simple and clear electronics tutorials.